We're nice.
Well, you say that, but and hello, welcome to Not an Audiophile, the podcast. This is episode 3, and today we're speaking with Alan March of Alan March Audio. He knows about amplifiers, but he also knows about jet engines. Roll tape. Welcome to the latest episode of Not an Audiophile. Today we have the, some say the amazing Alan March. Maybe he is. Oh, he's here. He's definitely connected. Alan, how are you going?
I'm doing very well, thank you, Andrew. How are you?
Good, thank you. Yeah, you sound good. And how's the weather over there? It's probably warm, actually, is it?
Well, it's actually sunny at the moment, but it has been throwing it down with rain. It's been pretty torrid here for the past few days, but
okay. Because we're supposed
to be
better. The country's supposed to be having some kind of heat wave, but it seems to be a little bit of a, maybe an exaggeration. It's warm for the time of year. There's no doubt about it, but clearly not in Albany. So you're in the business of designing and manufacturing amplifiers and loudspeakers under the brand March Audio. Now, where did you get the name from?
It is simply my name. I couldn't think of anything better to call it. No. We just went straight with my name.
And it works. So I think you started 5-6 years ago along those lines.
So sort of potted history. Myself and my wife Ruth, we emigrated over to Australia from the UK about 12 years ago.
Okay.
So we're Poms, but don't hold that against us. We're nice.
Well, you say that, but
there are varying opinions on that, I know, in the relative forums. But
well,
we're going
to obviously get to that, but so when you moved to Western Australia, there are a lot of POMs, as you described them, in Western Australia. I always feel like they came by boat and they were so sick of being at sea they just got off at Perth, which clearly is the first port you come to when you come from the UK or Europe or what have you. But that wasn't the case. Clearly, in your case, did you have a bit of a thing for the West, or what was the thought process there?
Well, it's quite simple. My wife Ruth, she's a civil engineer by training, so she's a very technical person, and there is an awful lot of mining engineering jobs available in Perth.
Yes.
And we came probably about when the mining boom was hitting its peak, and it was very simple to get a job in Perth.
Yeah,
so
okay.
We stopped.
Yep, very practical decision. Yep. And you've spent some amount of time on the East Coast. You happy with the West Coast?
Back in the UK, we were living out in the in rural areas, so we were probably, we probably like the rural areas more than the big cities. So Perth is actually quite a good introduction to Australia, if that's your sort of background. And we subsequently moved further into the sticks, down in Albany. So we're really out in the sticks now.
Yes, somewhat, I suppose, but I don't know from first-hand experience, because as a typical East Coaster, I've never been to WA, which is really kind of embarrassing, and partly laziness and also partly the fault of the airlines, who make it the same price to fly to Perth as they do to fly to a number of other international locations that are seemingly more exciting. But of course they're not. We know Perth is great, WA is great. Everyone I know who's been there loves it, and I know I'm sounding like an East Coast tosser, but I do intend to get there one day, and So 12 years ago that you moved there, but only 6 years ago that you started in the audio business specifically, or at least this particular enterprise. What did you do for the 6 years? Were you thinking up models, or were you working as an engineer? Because you are also qualified as I believe a mechanical engineer, but you can correct me as required.
No, so my professional background. So back in the UK, I spent most of my career working for Rolls Royce aero engines.
Okay.
Not the cars, because everybody thinks Rolls Royce, they think the cars. No, we're talking about jet engines here.
Yes.
So I started with an electrical and electronic apprenticeship at Rolls.
Well, my mistake then. So you were more on the electrical side. Apologies. I mean, that kind of makes more sense. It's just that people do jump engineering areas of expertise, I guess. So it's not unreasonable that you could move from mechanical to electrical, although it kind of is in some ways, since electrical is obviously much harder. But so electrical at Rolls Royce, is that right?
So we did sort of an electrical and electronic apprenticeship, so it's covered sort of both disciplines there.
Yeah, okay.
But you talk about the mechanical. Ultimately, what we were doing was applying that knowledge for the manufacture of some of the most sophisticated mechanical objects on the planet. Jet engines are really the state of the art in mechanical engineering.
Indeed.
So what I ended up doing was working as what they call a measurement engineer.
Okay.
So when you're designing and testing jet engines and jet engine components, you need to gather information about how they're performing.
Mm-hmm.
A typical example. So those big blades you see when you're walking up the steps into the aircraft and in front of the engine.
Yes.
Those compressor blades. One of the things you've got to do is look at the vibration in those blades. Basically, there's a very simple truism: if it rotates, it vibrates. So
yes, a girl told me that once.
Yeah. So you've almost certainly experienced this when your wheels on your car are out of balance. You get a vibration, and it comes through the steering wheel. And they need to be perfectly in balance. But so anything that rotates, it vibrates. So what happens when you get a piece of metal and you vibrate it backwards and forwards? It will start to fatigue.
Oh yeah, we don't want that.
And ultimately, if it fatigues too much, it will actually crack and then break. And one of those big blades falling off on a jet engine while you're flying in the sky will seriously spoil your day.
Oh yeah, I presume the whole thing would self-destruct almost immediately, would it? Because it obviously is suddenly dramatically out of balance, or what would actually happen? Other than we don't know where the bits go. Obviously, they go straight through a fuel tank, I guess, and leaving a fiery trail in the sky. But what would happen to the turbine, etc.? Do you think?
Well, the end. If one of those big fan blades fell off, it would definitely destroy the engine, and it's actually one of the tests we do to pass the certification tests.
Yeah.
One of those big blades is deliberately exploded off.
Okay.
But with an explosive bolt when the engine's running at full power.
Wow.
And that cowling must contain the blade.
Oh, is that right?
Because if it comes through the cabin space, that's going to be catastrophic.
Yeah, indeed.
Those cowlings are very specially designed to absorb the vibration and the shock of one of those blades falling off. And just to give you a sort of an idea of sort of how much energy it's containing, when one of those blades comes off, it's about the same energy that would be required to throw a family-sized car 100 feet in the air.
Okay, all right, that's
massive.
So what? I guess they spin very quickly, and are they made out of titanium or something, or what material do you think it is?
It does depend.
Okay.
Like the Rolls Royce big fan blades, they've got a technology where it's a titanium composite,
Yep.
but the blade is hollow. To reducing weight, the blade is hollow. They go into the two halves get pushed together in a furnace,
Yeah.
and sort of gas is flowed through the not molten metal, but the softened metal, and expand it out into the correct shape.
Okay.
So yeah,
I mean,
there's actually lots of videos actually on YouTube about all this sort of stuff. So if people are interested, they can certainly go and see that.
I mean, it is, as you said, it's absolutely at the high end of human endeavour, isn't it? Really.
Yeah, I actually believe it's more sophisticated and higher technology than sort of space technology.
Okay.
Because what these engines are doing, they're running reliably, probably 18 hours a day, every day, and they mustn't go wrong.
No,
The technology has got to that state now, where you've got turbine blades operating in an environment that's hotter than the melting point of the metal.
which kind of doesn't initially make sense, but yeah, okay.
Well, the only reason they don't melt is the turbine blades have these tiny, thousands of tiny holes drilled in the edge of the blade.
Okay.
And hot gas, although it's cool. It's cooler than the turbine temperature, but it's from one of the compressors on the front of the engine. It's still quite hot. It's several hundred degrees still. Is flowed through the blade, and it puts a film of gas over the surface of the blade to protect it from the very high temperatures.
Man alive. Okay.
So yeah, it really is. It really is incredible technology.
Yeah, it's breathtaking because, and it does make you wonder about the slow development in other areas of R&D or engineering, electrical, mechanical, or otherwise. In some ways, like people always offer up the example of the car versus aviation. If cars had increased in performance at the rate aircraft have over the last 100 years, they'd obviously, they'd do 1,000 miles an hour and wouldn't use any fuel doing it because, clearly aircraft have come so far. And really the jet engine has been around for, 70 years or something like that? Is that approximately right?
Yeah, approximately, yeah. Frank Whittle designed it end of the war. Mm-hmm. So yeah, it's got to be in that region, 70, 80 years. Yeah.
It's progressed some in that time, and I guess part of this care, this exceptionally high level of engineering is about efficiencies, and because obviously from the 70s, the Boeing jets of the 70s, the 707, 727, whatever, I mean, they left this nasty black trail across the sky when they were getting airborne.
The technology changed quite a bit. If you don't notice on those old jets, they are what they call a turbojet. So they're not actually very wide.
Yeah.
So
they were quite long and skinny, I guess, versus the current.
That's right.
Yeah.
There's two fundamental different types. Well, there's three. There's more than two, but two major types of jet engine: a turbojet and a turbofan. So a turbojet, most of the air goes through the core of the engine.
Mm-hmm.
But as you see on modern engines, they have that massive fan at the front.
Yeah.
And if you stop to look on steps and you look through, you can actually see all the way through the back of the engine. That's because the fan is blowing a lot of the air around the engine. So that has a multitude of advantages. There's sort of two concepts. Most people don't understand how jet engines actually make it go along. So if I said to you this, if you could complete this sentence,
sure.
Every action has an equal
and opposite reaction.
Correct.
Or action or reaction?
Reaction.
Yep.
So jet engines work on the simple principle: if you move a ton of air backwards
Yes.
out the back of the engine, you'll get a ton of thrust forwards, and that's what pushes the engine along,
Yeah.
the aircraft along.
Yep.
People have strange concepts about how it's pushing against something, but it's not. It's just simply reactive force.
Yeah.
So a turbojet moves a smaller amount of air more quickly, and that can be noisy,
Yes.
and not as efficient.
Yep.
But it's better if you want to go fast. So you'll still see turbojets in more military applications these days.
Okay. So so is this?
They need to go fast.
Yeah. Sorry, I didn't mean to cut you off.
Yeah,
Turbofan, then, which is the modern engine for passenger
Civil
jets.
engine,
Yeah.
is moving larger amounts of air more slowly.
Okay. And so is that?
So it's the mass of the air you move that is the thrust.
And this, of course, is this. All this is relevant regarding your amplifier designs, but we'll come back to that. Your jet-powered amplifiers. So is this? Do you think a limitation of why we're not flying around at Mach 2 or something? Is it because, other than the airframe obviously is not appropriate for that speed, but is it because of the jet? The sweet spot for those jet engines is at Mach 0.75 or 8 or whatever we travel at normally, whatever they cruise at. Is that that's part of the engines? A part of that reason or equation?
Yeah, it's primarily cost.
Yes. Yep. Cost of
fuel.
You
want to go back to cost of fuel,
yep.
and just the cost of the technology involved.
Yeah. Okay.
So, I mean, I worked on Concorde.
Did you? You just dropped that into the conversation there,
yes.
as if everyone has had a crack at working on a Concorde. But so, of course, there's a whole podcast right there, I guess.
In itself.
Yes.
Yeah, it is. It's a fascinating subject. So my involvement, I'm old, but I'm not quite old enough to have worked on it through development. But I worked on it after the crash in France.
Okay.
We could leave that for another one because it's a very.
Well, we don't have to leave
subject.
it, but yeah, I will, only because I think. I mean, clearly we're going to speak to you more than once at the podcast here. Podcast being Not an Audio File. Details available at notanaudiophile.com. And by the time this is up, available on iTunes and YouTube. I think that was an ad. This is all very impressive and very interesting. And you have a skill at explaining these things in such a way that someone who knows nothing about jet engines, such as myself, has half an idea, or at least I think I do, how they might work. But yeah,
people don't get exposed to it. That's why. The technology what happens with jet engines, and we all get on aircraft, but we don't think much about it unless there's some horrible bangs and crashes that scare you to death.
Yes.
So it's. One of the things that I can absolutely assure people is the amount of quality control. I won't speak for Boeing at the moment, but certainly the quality control
of the engine builder,
of the engine of Rolls Royce, yes. For example, was extreme. It was absolutely extreme. The engines are hand built. And someone doing up bolts on the engine would have someone following behind them inspecting it. That sort of thing is going on. Every instrument you use to measure anything is calibrated. It's traceable back to national standards. Yeah. And if it then, when it goes to get recalibrated, it fails, there has to be a whole investigation about what that instrument was used on and could it affect product quality and so on and so forth. Yeah. So, that's something I've taken. That sort of attitude to quality control is something I have taken through into this business.
Which leads us neatly full circle. Which I don't want to. Let's go back to jets for a second, but we will come back to amplifiers. So we're going to have a quick break before we do. But that level of quality control, which appeals greatly to me, but I guess it comes at a cost. There's a lot of effort put into that aspect of it, and that's one reason why The engines are expensive, I guess, but I'm also impressed by I'm impressed by the cost of a bolt and things like that. I mean, have you got any? I was speaking to a lamey came in the shop with a repair or something, and he was working out at the airport. We were not far from the airport for Qantas, I think, in their maintenance. Assuming Qantas still has a maintenance division. He was giving me some examples of fastener prices. $120 for a bolt or something like that, and it wasn't a very big one. You probably have some staggering examples of parts prices. You probably don't know the price exactly, but the torque around the hanger kind of thing. Of course, you probably did. You work in hangars? Did Rolls Royce have a facility at an airport, or you're all working off on somewhere near an airport, or what's?
So Rolls Royce has two divisions: the civil aircraft that we all fly on to go on holiday, and the military aircraft, military engines. So the civil's based in Derby in the UK, and the military's based in Bristol, which is where I'm from. So I actually spent most of my time working on the military side of things.
Oh, yeah.
But I was in what they called the off-site measurement team for a many years. So we were the ones that were sent off to Timbuktu when something didn't work, or you had to do some testing of an engine, maybe at a customer site. So it could be a Royal Air Force site that are using our engines. A lot of the American Navy used to use a lot of Rolls Royce engines. They use the T-45 aircraft with the Ador engine for training.
Mm-hmm.
And before the F-35 came along, they used to use Harrier jump jets, which is another Rolls Royce engine.
One should hope that it would have a Rolls Royce engine. Surely appropriate.
They used to love the things. That's another story. But the Harrier jump jet is much better than the F-35. But we won't go into that at the moment.
We will. We'll add that to the list. So we've got Concorde, and we've got the Harrier jump jet for future episodes. Even though this is apparently an audio-related podcast, It's audio is so incredibly dull and uninteresting compared with what we've just spoken about, though. But a little bit more real world.
We'll get to the relevance.
Well, the reality is that none of us are going to have a Harrier in our backyard and nor be capable of flying it or maintaining it. So, whereas an audio system, we can probably manage that. We're going to have a quick break. We're going to have a quick break, and we're going to come back and talk about amplifiers. Is that all right?
Okay, absolutely.
All right. Thank you, folks. See you soon. Delacord loudspeakers, an Australian-made product, designed here, manufactured here. Sold worldwide, sold around Australia through various dealers, but also on display coming up at the Australian HiFi show in Melbourne, early to mid-October. See us there, have a chat, have a listen. In the meantime, check out delacord.com.au. Back to the show. Hello, folks. We're back at Not an Audiophile, the podcast about jets and other interesting stuff, and sometimes audio gear. We have Alan March from his calling in from his HQ in Albany, Western Australia. Western Australia being in the western part of Australia. Australia being in the lower hemisphere of the world. So, amplifiers. You've of all this knowledge of testing, measuring jet engines, and you've applied, I guess, from what you implied, you've applied some of that quality control, if you like, to your own product. But how did you get into amplifiers? What drove you there?
Well, I'll explain the relevance of my sort of previous professional background to audio electronics, because people will be going, what on earth has jet engines got to do with audio electronics? So as I mentioned earlier, my role was a measurement engineer. So what we would need to do is test, when you're testing components and engines, you need to measure how they're performing, how they're vibrating, what pressures, what temperatures are happening. And these could be using pressure transducers, strain gauges, vibration transducers, and all sorts of other different measurement techniques, including X-ray. We even use X-ray engines.
Did you have a wooden school ruler? Did you?
Yeah.
You had a wooden school.
Absolutely.
Keep going.
Fully calibrated, of course.
A calibrated one. Oh, the expensive version. Of
course, yes. So the electronics and recording systems that we use to record that information, it's all a small electrical signals that aren't dissimilar to audio signals, electrical signals that we have in our domestic hi-fis.
Okay.
In fact, there's no real differentiation apart from it's not music.
No, I suppose not. Yes.
And I mean, like strain gauges for recording the strain in a component when an engine's running.
Yeah.
I mean, you can actually get strain gauge cartridges for turntables.
Okay.
So they use that technique instead of moving a magnet or moving a coil.
Okay,
they flex a strain gauge.
As someone who works on turntables a lot, I'm excuse my ignorance because I'm clearly very ignorant. So I've vaguely heard of that, but what do you? So you fit this particular cartridge instead of a normal magnetic cartridge or whatever, and you measure what with it and how? Just as an aside.
A strain gauge measures how much flex there is on a jet, typically a metal component.
Yeah.
How much it flexes and moves. So you can apply that technology into an audio cartridge. So the stylus makes a piece of metal with a strain gauge flex on it.
Yeah.
Well, it doesn't have to be metal. It could be some other relevant material.
Yeah.
And it causes a resistance change in the strain gauge, because all a strain gauge is a resistor on a sort of plastic sheet.
Yes.
Flexible plastic sheet. So that varying resistance gets changed into a varying voltage or current, depending on how you do it.
Yep.
And hey presto, you can get with a suitable amplifier, you can get your audio signal out the other end.
Yeah. Okay.
So basically the point I'm making is that everything we were doing was no different to audio electronics.
No, by the sound of it, yeah.
We even used to use reel-to-reel analog tape recorders to record vibration.
Okay.
Because they're literally audio frequency signals, maybe up to 80 kilohertz. And we used to use 28-track. They were developed from audio tape recorders.
Yeah. Okay.
To record the data. We subsequently moved to digital, but the digital acquisition systems are, again, no different to any digital audio acquisition system. They're identical.
Yes.
So all these signals are coming out of an engine, out of a test bed, and they have to be what they call signal conditioned, maybe amplified, maybe filtered.
Yeah.
And the really important thing, going back to the quality control, you have to make sure that the data you're recording is absolutely accurate. Because that data goes back into the engine design.
Yeah.
And if you screwed something up and you're measuring, I don't know, 20 kilopascals instead of, and it's actually really 25.
Yes.
The ultimate conclusion is that something serious could happen in flight.
Yes.
Because they might change the design based on that. They think, oh, that's okay. That pressure is okay.
Yes.
And it may not.
Yep.
So the quality control. So what we're doing is sort of like a studio recording engineer, but with much greater discipline.
Well, yes.
It's not to get an artistic effect where you can do anything you like. You can add distortion, you can add echo, and all stuff like that. It's just to make it absolutely accurate.
Yeah. Which is a skill, because getting fake measurements out of things, or not measuring something in the correct way or using the correct technique, can of course throw up some sort of useless data, I guess. It's a number, but it's, as you say, you've got to make sure it's the right number.
Correct.
And it's consistent. And so I mean, hence you were busy with that. And how many years did you do that for, by the way, that measurement job at Rolls? Probably a good while, I'm guessing.
Yeah, I worked at Rolls for probably about 18 years.
Wow. Okay. You must be older than you must be older than you look, eh?
Yeah, I'm in my 50s, so yeah, getting there.
50s, eh? Yeah, well preserved. It's
Yeah.
that dim, rarely seen English sun, I guess, that hasn't worn
But
you out.
yeah, in measurement engineering itself, probably about 12 years, I'd have said.
Okay.
Yeah,
Yeah.
about
Right.
there.
All right.
Well, I mean, another thing we used to do as part of the test system. I mentioned about testing blades with vibration.
Yes.
We used to use these shakers that were powered, these massive shakers that would shake engine blades, and you'd put strain gauges all over them and measure the stress and strain in the blades to make sure they're not going to fail in service.
Yeah.
But we'd be using audio amplifiers to shake them, to drive the shakers.
Yeah. Rightio. Yeah. Yeah. So you're not buzzing them at particularly high frequencies then, or I guess you sort of do a sweep and try to find the resonances or something and really nail them.
Yeah, that's absolutely correct. So every object has a natural frequency. If you say flick a wine glass with your finger, you'll get a ding, and it will resonate at a certain frequency. A jet engine blade is exactly the same.
Yeah.
You flick it,
Yep.
it will vibrate at a certain frequency. And so you want to make sure that the blade is designed such that it doesn't vibrate significantly at the wrong frequencies.
Yeah. Within the operating range, I guess.
Range of the aircraft, yeah. Absolutely. So, and then we shake them and heat them up to the relevant temperatures with induction heaters, and you'd vibrate them. So yeah, I used to look after repairing and very large, high power audio amplifiers. I mean, we're talking about 5-10 kilowatt amplifiers to drive these shakers.
Yeah. Okay.
Yeah.
So they've probably all gone Class D now, I suppose, have they?
Well, believe it or not, when I was there, we were still using some valve amps to do it.
Oh, is that right?
Yeah, these things were massive. They're absolutely massive.
What tube? Like some kind of broadcast transmitting tube or something? What?
I can't remember what it was, but I mean the main tubes in the amp I'm thinking of, they were probably about 100 centimeters across.
Yeah.
And about,
100 centimeters, a meter across.
Sorry, 100. No. Sorry,
100 mil.
Millimeters.
100 mil. Okay.
And probably about 300 millimeters tall.
Now that's a serious tube. Yeah. Okay.
It's a big tube. Yeah.
All right. I think I knew the 3-digit code for that tube once, but my memory is not what it once was. But I did. There was a design or two out there with a single-ended amp out there with one big sort of transmitting tube in it, which is possibly similar to that or the same. Yeah. They're impressive,
but most of those amplifiers were, for those who are familiar, they had 100 2N3055 power transistors on the output. They were a horrible design because each one had a fuse, and if one of them failed, it would trip the amplifier, and then you had to go and find the right one that had failed.
Oh dear. Yeah, okay. Each output device had a fuse.
Yes, because they were just literally paralleled up.
Yeah, wowee, okay.
And if they go, they're being driven hard, and if they go short circuit, then you put very high voltage onto your shaker, so that's not great.
Not great. And 2N3055 is the workhorse of TO3 power transistors, has been for my whole career. I guess it was invented late 70s or something like that. Maybe before that, maybe mid 70s. So maybe this gear was all built in the 70s anyhow, by the sound of it.
Well, it was old stuff. Yeah.
Yep.
Very expensive stuff, and a lot of the stuff you couldn't buy off the shelf. Rolls Royce had its own electronics design department that would build specialist stuff because you just couldn't buy it. where needed.
Yeah, well, indeed. I mean, if you need a 10,000 watt amplifier, there's a limited amount that you can buy. So, wow. Okay, all I've got is wow. So just stepping sideways then. So the bit that we've left out is the step where you. I mean, I assume you spent some of your earnings at Rolls Royce on audio equipment. Is that what happened?
Of course, yes. I mean, I've been an audiophile, maybe not a traditional audiophile, but I've been.
You realise before you go any further, yes, to be on this broadcast, you need to be not an audiophile. So you were, but you're not anymore. Okay. Now, so you were an enthusiast, and you had. What did you have? You had a Lin name system, right? Of course. No,
I did probably everything that everybody else has done with audio electronics. I was interested in audio electronics and music from the age of about 10 onwards.
Wow.
And
okay. So you go way back.
So as soon as I started earning money, then I started buying hi-fi. So let me think. I mean, I've gone through Name gear, Meridian gear.
Yep.
I started off with NAD. I had a 3020. Everybody had one of those.
Yeah, except me. But I mean, they were a charmer. There's no doubt about it. They were a charmer and they were a bargain. So built a reputation on one model. So yeah.
Yeah, I mean, I had one of those very early Philips CD players.
Yes. Oh, the vertical aligned CD?
No, it wasn't one of those. It was a 104. I can't remember. It's a very long time ago. That's 40 years ago.
Well, yeah. What do you mean you haven't got it anymore?
No.
Okay, so you've...
Actually, the kit I kept for a very long time was I eventually got a Tag McLaren AV system.
Okay, right, yeah.
And that kept me very happy for a very long time.
Is that right?
I mean, I went through all sorts of different speakers, Sonus Faber, B&W, all sorts. Yeah, lots of different things there. Kefs, yeah. But yeah, I was a serial upgrader at that point.
I think Philip Swift and his partner at Audio Lab would be very impressed with hearing you say that, because I'm pretty sure the Tag McLaren was a spin-off of Audio Lab, the original Audio Lab. And they used the design, the various amplifier designs got rolled into the Tag McLaren gear.
That's correct. Yeah, they basically Tag McLaren decided they wanted to get into high-end audio for some reason,
some unusual reason. Yeah.
Well, Tag McLaren had fingers in all sorts of pies, from aviation to obviously watches, and it's sort of high-end esoteric stuff. So they started by buying Audio Lab.
Mm-hmm.
They then, as you say, updated the designs and brought out their AV processor.
Mm-hmm.
And that was truly what I would call a hi-fi AV processor, because most of them these days aren't actually very hi-fi at all.
No, they are not. No.
I wouldn't use any of them for music these days. But that Tag McLaren really was high quality for audio as well as the home theatre.
Yeah.
And then eventually they I think the story basically is they weren't selling at a high enough price.
No.
They were only making. They were doing high end stuff and making very little money on it, and that finished them off in the end.
And that was that. Yeah, I don't know whether it ended badly or they just made a decision to sell out of it. I don't know. And obviously IAG bought it at auction or something, as IAG tends to do. But
that's right. That's right. Yeah, IAG bought all the designs and the rights and everything, and rolled them into their products.
Yes.
So the loop goes around.
Yes, it does. It travels to the other side of the planet and starts again. So great. You you've mentioned mostly what were effectively local products for yourself, but what great local products. I mean, England is a great place to have an interest in hi-fi because you almost you don't need to buy outside of the country, really. There's so much good stuff still made there, even today, really. No, perhaps not as much as there was then. So
it's take a bit of a dive now, but certainly was when I was younger.
Yeah, it was in its heyday, I guess. So you're interested in. So you've clearly got an interest in audio, and you have had since the age of 10, approximately. But what about the interest in manufacturing? Does that come from seeing it happen at Rolls Royce? Is that sort of what tweaked your interest there, or is it just you just wanted to create something, or what were your thoughts there?
Well, yeah, I mean, from a personal perspective, I love building shit. It's I just I've always say it's not just audio; it's audio electronics. So I've been interested in electronics in general. I through for decades I was playing with electronics and building my own things and done a few speakers and things. The actual creative process. I love the design work. I've been sat this morning doing PCB design work, and I just love doing it. And then you see a product come out at the end of it, and people like it.
Yes,
it's fantastic.
Yeah.
So I wouldn't say I'm actually interested so much in the manufacturing process.
Yeah, as the design part and development part, perhaps.
Correct. Yeah. That's what my real passion is, shall we say?
Yeah. Well, clearly. So, I mean, your product looks fantastic. It's certainly sensibly priced. It performs extremely well at the amplifiers I'm referring to. Oh no, I mean it does. It's well regarded. In fact, the amplifiers have been around for quite a while, as we said, like 5 or 6 years or something like that. But in more recent times, you went off sideways, as we all do at some point in our life, and built some speakers. Do you want us to tell? Do you want to? Because the difference between your loudspeaker and say the one that we do here at Delacord, or Sir Hannah Swift, or Proac or Spendor, or any, is that you've got these drive units with the broken surrounds. I mean that's the difference, right? So I suppose that product came out and you went, oh, I could build a speaker out of that would solve a problem. In fact, tell us why those drive units have the weird looking surrounds, because I'm pretty sure there's a good engineering reason for it.
It is. There's a very good engineering reason. So we're referring to the Purify drivers. So that crinkly-looking surround there's a very good reason for it. If you think about a normal what they call a half roll surround, sort of the semicircle surrounds that you get on most drivers.
Yeah.
What happens when the cone moves backwards and forwards is that cone deforms and it changes shape.
Okay.
What it's actually also doing is not just changing shape, it's actually changing the surface area of the driver.
The surround is changing shape, or the cone, or both is changing shape? You said the cone is changing shape, which it probably is, but did you mean the surround, or you mean the whole combination?
Sorry.
The surround cone combo?
The surround is changing shape.
Yeah.
The surround is changing shape.
Yeah, okay.
The cone does. We won't go into the modes in the cone as well.
But clearly it's changing shape to some subtle degree as well, no doubt. Yeah. But so the surround is it's clearly changing shape. Yes, as the cone. I mean, obviously on bass frequencies, the cone is excursioning a decent distance, say plus or minus a few millimeters, or more, and so the half round surround is stretching effectively, I suppose. In some ways,
correct. And that leads to the surface area, the radiating surface area of the entire driver cone and surround, because it's all radiating sound.
Yes.
Changing, and that change in surface area leads to distortion.
Mm-hmm.
There's a distortion mechanism there. So what Purify did, it's a spectacularly simple idea, is that they designed the surround so half of it sticks out and half of it sticks in.
Ah, yes, that makes sense now that I think of it. Yes. In what, half a dozen segments or something like that, or four?
I'd have to. I don't know. I'd have to. I've got one over here. I'm just going to buzz over and have a look, and they've got 1, 2, 3, 4 sticking out and 4 sticking in.
There you go. Okay. Yep. So one balances the other, or something.
Correct. So the surface area remains the same wherever it is on the travel of the cone. Second thing it does is it keeps the restoring force on the cone equal,
consistent. Yes.
Wherever consistent, wherever it is on the travel of the cone.
Yeah, that makes sense. Yes. Yep.
With a half roll, the restoring force is very different from just maybe a millimeter to say 5 millimeters.
Yeah.
And it will be different whether it's going in or going out as well because of the nature of the shape.
Yeah. Although they say, whoever they are, that most of the stiffness of the suspension is down to the spider. Is it different with these drive units? So maybe the spider is somewhat more compliant, the surround takes more of that roll on due to its complexity or something? Or do you have any thoughts on that? Or is that not something you don't need to concern yourself with to some degree?
That's actually a very good point because Purify, what they do is they're a technology company. They're sort of intellectual property. They don't want to build stuff. They don't want to build amplifiers. They don't want to build speakers.
No.
They develop technology for us OEMs to implement.
Sure.
So they don't tell us everything about how it works.
Okay.
They'll give you a good idea. So I couldn't tell you the relative merits of the surround versus the spider in terms of what we're talking here. Lars is very helpful from Purify. He might, if I went and asked him, he might tell me, but it's not something I've bothered to investigate because it works.
Because you're only really interested in how it works as a whole. Really, it's yes. But it is quite a different drive unit design because of the complexity of the surround, I guess. Which surrounds? No, I don't know if they're an afterthought, but and I don't think they really are. But I mean, they are. They have. We talk about the change in aviation versus the lack of change in other areas. I mean, roll surrounds really changed once only until these weird-looking ones that you're using, probably ever, when they went from some kind of ribbed fabric surround to a more compliant rubber or foam half-roll surround. But
and this is what Purify did when they decided they were going to make drivers. They just sat back and said, like, well, okay, what are the problems?
Yes. Yeah.
They identified a number of specific problems that traditional drivers suffer from, and set about trying to solve those problems.
Yeah. Well, they've no doubt achieved it. I mean, the looks, the aesthetic is somewhat polarizing, I guess. I mean, it's interesting for technical types. I sometimes wonder whether the lady of the house is attracted to that slightly insect-like surround. I mean, in the sense it looks a little bit like a centipede or something crawling around the perimeter of your driver. It's not that bad.
I've seen it likened to some Chinese dumplings.
Yeah, there is a bit of that too. Yeah. So
but we do grill to cover it up if people feel that.
If they can't deal with it.
When we do hi-fi shows, it's people come up to me literally every 5 minutes. They wander in the room and go, ooh. They either go, your speaker's broken,
yes,
or what's it all about? And
Yes.
we have to explain it. We do it very patiently. We have to explain it probably about 100 times a day.
Well, not now, because this wide-ranging broadcast that everyone with an interest in audio is listening to, they've now had it explained to them, so you'll no longer receive that question. It's. I suppose if we just talk on the speakers for a second, and why not? Although we will once again take a brief break in a second. But the highly radiused edges, is that something you're very? I mean, because there's not two schools of thought. I mean, in reality, it must assist with baffle diffraction related issues, I guess. But is that what you're trying to deal with by going for probably a 25 mil radius on the box or something?
Yeah, absolutely spot on. It never ceases to amaze me how many speakers are still using sharp edges on the corners. It's a very well known issue that as the pressure wave radiates along the baffle from the driver, that if you hit a sharp edge, you'll get this diffraction effect. And it really needs a video or some drawings to explain it. But it basically, the sound wave, how shall I say it sort of breaks off at that corner at that sharp edge, and you get constructive and destructive pressure waves mixing with the main sound coming from the main cone. So you'll get as you move around the speaker, you'll get peaks and you'll get dips in the amplitude of the sound. So yeah, if you're at a particular angle, you might get a peak, and if you're at another particular angle, you'll get a dip. So the radius helps mitigate that. It won't solve it completely. You actually need a much larger radius than that to really solve the problem. But that combined with the waveguide, the waveguide on the tweeter does significantly help the issue.
Yeah, and I think, look, certainly from a theoretical point of view, I absolutely and utterly agree with your, with your design process. I mean, there are issues with that, and you've addressed them as realistically as you can, because obviously, it's impractical to have a 100 mil radius or something on the edge of the baffle. But you say, why do manufacturers still make pointy edge boxes and don't attempt to deal with that? Is that that's what people want?
I was just about to say
some people just they'd like.
Yeah,
they
you can't as a manufacturer, you can't necessarily do what technically is correct, because it is aesthetically too radical.
Yeah, it's a weird thing that the same could be said, and the analogy could be made for cars and other things. I think if you think about cars for a second, an ideally slippery aerodynamic shape, like one that really is good, built a little bit like a light plane, nice and narrow, people just don't want. They would never buy it.
Absolutely.
Yeah.
You see all the concept cars that the manufacturers make before they bring a concept into manufacture. It gets toned down so much from what the concepts look. Wow, look at that's amazing, futuristic, and then it comes out looking like a Trabant or something. It's
maybe not that bad, but I've run what would you call it? What the film producing people do, where they get a room full of people and maybe play them the end of the film or part of the film and ask questions and trying to form it's a terrible way to make a movie, of course, but that's how Hollywood does it. They're there to make money, I guess. But you ask people about aspects. Like I once asked a bunch of people about, and I've mentioned this to Brad Surhan, who is a fan of asymmetric tweeter positioning, and which obviously helps with edge diffraction as well.
But it is mostly the right thing to do.
Yeah, it's a reasonable. Oh well, it doesn't. It spreads the problem around, and it's a good thing to do. It's certainly not as good, perhaps, as what you've done, but it creates a similar polarisation. Some people just don't want the tweeter off the centre line. They will not buy that loudspeaker. And then I once designed something that didn't even have symmetrical tweeters, so I had the tweeter 15mm off the centre line to the left on both left and right speakers. People were freaking out, leaving the room, throwing up into buckets. I'm sorry, I quite like it. It's I don't have a problem with asymmetry. Some people, it's vomit inducing. So, and this is, unfortunately, there's this, you have to sort of balance these decisions, these engineering decisions, against people's expectations, I guess. But it's good to understand. So that and of course you did mention the well, actually, before we get on to the I'll call it the horn-loaded tweeter, just to annoy you. We're just going to have a break and come back and discuss that horn of yours. One tick.
Okie dokie.
Okay, back soon, folks. Delacord loudspeakers, an Australian-made product, designed here, manufactured here, sold worldwide, sold around Australia through various dealers, but also on display coming up at the Australian HiFi show in Melbourne, early to mid-October. See us there, have a chat, have a listen. In the meantime, check out delacord.com.au. Back to the show. So, and we're back. Not an audiophile is back for possibly session 3 in this episode, which might be the last. Alan March of. I'm just going to start again. All right, so. Stop laughing. It's Andrew Hutchison here with Alan March on the Not an Audiophile podcast, discussing Alan's fine range of audio products and perhaps the reasons why they are designed the way they are, and how he got both to the industry from jet engines at Rolls Royce, and of course we find out that in fact he's had an interest in audio for his whole life, which I guess we all probably have. And we haven't talked about music yet, but we'll come back to that. But but what we were talking about is his loudspeaker designs and the reasons for the oddball surrounds and the benefits that they offer. And also we touched on the large radius or big radius baffle edges, in fact cabinet edges, full stop. And we're going to talk about the horn-loaded tweeter, which of course is not horn-loaded, although it kind of is, isn't it? I mean, that is how it works, is that it's...
Absolutely. I have been known to state my distaste for very large, those massive horn speakers that you sometimes see at hi-fi shows.
Kind of things they use at race courses for public address.
They've got a horn that's 3 or 4 feet wide or maybe bigger, and I'll probably upset a few people with this, but I've always found them sounding...
You've never upset anyone with your comments?
I've never upset anyone. I've always found them to sound coloured and not natural.
Many do, but not all. I'll say that.
That's correct. Yes. It's an unfair generalisation. I do realise that, but I've heard many units at many hi-fi shows over the years, etc. I think I've probably heard one that I went, okay, I can get on with this. I can live with it. And there's a good reason. Technical reason why some of them do sound coloured, and it's directivity.
Okay.
What we hear with speakers is so much about their directivity properties, and large horns that have got very narrow directivity, their direct sound, what you're hearing coming directly at you, face onto the speaker, is actually very different in frequency response and timbre from what's being reflected off the walls, floor, and ceiling.
Okay.
Because of the narrow directivity, and there's plenty of research on this. I'm sure you're fully aware of Mr. Floyd Toole and the research he did on subjective speaker preferences compared to sort of technical design. And one of the principles is that the timbre and frequency response coming off of the reflections in the room needs to be similar to what's coming directly at you from the speaker.
Indeed.
And again, that's all down to the directivity of the speaker.
Is that sort of related, or is the power response, or that's part of that sort of discussion? I mean, the power response being the balance of sound that fills the room, or what have you?
Yeah, I suppose it's a term we need to explain to people, because if you haven't done any acoustics work, you might not understand what that means. So I expect most people have heard of sound pressure level.
dB.
So what that dB? Yeah. Well, it's measured in dB. A dB is not a unit; it's just a ratio way of expressing a large ratio between two numbers. In fact, dB is a funny thing, isn't it? It's hard to grasp in a way. Maybe just two seconds on dB, because it's quite an interesting. You explain it as you will do much better than I can. So far away. Just briefly. Look, it's funny. I've listened to a lot of audio podcasts over many years. I don't think anyone's discussed the relationship of dB and maybe power, audio, acoustic power in the room or whatever. So far away, Alan. Yeah.
I'll leave it at your feet.
Okay, so dB. So dB is not. People think it's a unit of measurement, a unit of how loud something is, and it's not actually that at all. It's like a millimeter is a definitive measurement of distance.
Yes.
But what dB is a way to express a ratio between two numbers. So the thing with audio is that the human hearing, well, animals as well, covers a massive range of pressure levels. So what we hear is the pressure of air moving against our eardrums.
Okay.
And we can hear from very tiny low pressure measurements up to very, very high pressure measurements.
Mm-hmm.
And literally, our threshold of hearing in terms of pressure is 20 micropascals.
Okay.
So
it doesn't seem like much.
It doesn't. Well, let's put it this way: atmospheric pressure is let me see, is it 15 kPa?
I thought
15.
I was hoping you had the answer to that, because I've forgotten it, because I don't do kPAs. So,
well, I should know this.
I think you should,
because it's absolutely critical to testing jet engines.
Yeah. Well, I'm sure you did know it.
Oh, sorry. It's 14.7 psi.
Yes. That's the number that. Anyhow, keep going. Yeah, that was the number that absolutely rings a bell. Yes. So
in
Pascals, or kilopascals.
It's 101 kPa.
Is that what it is?
101,000. Okay. So that's just atmospheric pressure.
Yep.
So you've got a difference between you've got a difference between micropascals and thousands of pascals, kPa.
That's so. Hang on. So you're talking micropascals versus kPa. So we're talking 1,000 million.
Yeah, so let me just look up. I mean, they say like 120 dB is the threshold of pain, generally.
Depends what music you're listening to, really. I mean, clearly Celine Dion at probably 75 is unpleasant, but keep going.
I'm just looking it up. I'm trying to find a calculator on the internet to see what it is.
Probably the internet's pretty slow and open. Are you still on dial-up there, I guess, are you? Or what's...
Well, we're on Starlink. It's fantastic.
Oh, okay. Yeah, so I've just made a fool of myself yet again, because you're clearly... you've got faster internet than I have.
being in the sticks, we have no connection at all, so we're on satellite.
Okay.
Anyway, so going back to TV.
Yes.
So if you've got to express the audio volume levels in pascals, it would be you'd be using numbers with either lots of zeros up front or lots of zeros behind.
Indeed.
So it becomes unwieldy.
Yes.
To use. So what dB is, now the threshold of a hearing, as I already mentioned, is about 20 micropascals.
Yes.
And what is always omitted when you see like a sound pressure level measurement of, say, 95 dB or something, is the fact they should have on the end of it reference 20 micropascals. So it's a ratio of, say, 90 dB.
Yeah.
Higher
than 20 micropascals.
20 micropascals.
Yeah. Okay. Which is the threshold of audible sound.
Correct.
Yeah. Okay. So the lightest wisp of a hummingbird's, well, we'll say feathers, at a distance is 20 micropascals. You can just hear it in the middle of the night. And then 95 dB is clearly, Well, 95 dBA is the threshold of, dB is the threshold, might be A-weighted or whatever, is the threshold of where you're supposed to wear hearing protection, I think, isn't it, or something like that?
Well, this is actually some of the job I used to do, because when we came over to Australia, I started working in an engineering firm in a noise and acoustics and vibration department. And one of the parts of my role was being a noise officer. So I did do some work going to industrial sites, maybe mine sites, monitoring and assessing noise levels within for health and safety reasons. So basically in Australia, you're allowed to hear 85 dB for up to 8 hours a day.
Is that right? Clearly without hearing protection, 85 for 8 hours is okay.
That's okay. So hearing damage
seems pretty loud. Yeah, okay.
So.
Yeah, okay.
Hearing damage is level multiplied by time, effectively.
Yes. Okay.
And again, going back to the dB thing, a 3 dB increase in volume is notionally twice the amount of power. So what happens is if it goes up 3 dB, say from 85 to 88, you half the amount of time you can listen to it for.
Yeah, makes complete sense. Yeah, okay. Which then means that 95 dB, you can listen to it for a tenth of the time, I guess, that you would at 85.
Yes.
Yeah.
Correct, yeah. And you very quickly, when you go up, you start getting into very short periods of time before you start risking damage.
Yeah.
So,
well, yeah, because if you're under an hour at 95, then you're clearly under probably under 5 minutes at 105. Which
that's it. Yes.
Which is and I mean 105 is loud, but it's not that loud. I mean, a decent stereo turned up in the seated position is probably 105 dB. And when I say decent, I mean a very decent one, I suppose, but and one perhaps more biased towards playing loud than in a high fidelity fashion. But that's a great explanation, because I don't think anybody really thinks about that too much and relates the pressure of sound to the dB thing, and you've done a nice job of that. Thank you very much. Which brings us back to horn-loaded tweeters. Because you're talking about directivity, and you talked about Floyd Tool, and we're talking about power. Power response.
Sound power.
Yeah.
So the difference between sound pressure and sound power.
Yes.
So sound pressure, when you measure it with a sound level meter, is literally the pressure level that you're receiving at that point in the room.
Yeah.
Sound power, on the other hand, so you've got an object that emits sound. It could be anything. It could be your fridge. It could be your speaker. It could be your car.
Mm-hmm.
the amount of sound power an object emits is the amount of power it's emitting in all directions.
Yep.
So ideally, you want to measure that in a sphere around the object.
Yeah, okay.
So it's the total amount of energy that the object is emitting. Now, speakers, people don't necessarily think about it too much, emit sound in all directions, particularly at low frequencies.
Indeed.
So it's not just what's coming forward from the speaker at you, from the front, because the speaker's emitting sound in the back, it's in the side, in the top, in the bottom, and the thing that it's doing is it's changing how much sound power is emitted dependent on frequency.
Mm-hmm.
At very low frequencies, speakers are omnidirectional.
Yeah.
So the bass goes everywhere in all directions. At very high frequencies, what the tweeter's doing, it becomes directional and tends to be, when you get to 20 kilohertz, it gets to a point where it's almost beaming, depending
Indeed.
on the design.
Well, yeah, size of the diaphragm, I guess, to some degree, as well. Yep. So, is this where the horn is this where this is this? It's there to tweak the directivity. Then,
that's correct. So another interesting property of any object, it's not just speaker drivers, any object, is its directivity is, if I can explain this properly, its directivity is dependent on how large, physically large the object is compared to the wavelength of the sound it's playing.
Mm-hmm.
So if you have a very large object, like a woofer, trying to play a very high frequency, i.e. a very short wavelength, it will beam the sound.
Yeah.
But a very small object, like a tweeter, playing the same frequency, will have a much, much wider directivity.
Indeed.
It'll become more omnidirectional.
Yeah.
So that's why we have tweeters. I see sometimes these single driver speakers, and they don't work. Simply do not work because you
heard it here first.
I'm being controversial.
You're not really. I mean, they don't work. I mean, but they can sound sort of. They have their own attributes, I guess, which some people like. But yeah, I mean that is why the 2- or 3-way speaker was invented, right? So just keep on with the thought process, because So to summarise, basically, wider diaphragms beam. And by beam, I guess we mean have very narrow directivity, like a 10, 20 degree range in any direction, I guess, out into the room from the front. So you really need to be standing directly in front of the speaker to hear a broad range, an even-ish frequency response. But of course,
correct. Yes.
And now I guess maybe those full-range speakers that you're alluding to, the Louthers of the world and others, I guess they do produce a bit of high frequency in their slightly ragged, uneven kind of way, on axis. They probably are full range on axis. Would that be it?
That's it. It's possible to design maybe a 4, 5, 6 inch driver. I think with some difficulty, to be relatively flat frequency response directly on axis.
Yeah.
But the moment you start moving off axis, because of the beaming effect of the large size diaphragm, the high frequencies, they will be beamed, but the low frequencies will be very spread out. So, and as we listen in rooms.
Yes, we
do. And what we hear is a combination of the direct sound and the reflections off of all the floor, walls, and ceiling.
Yep.
And as I mentioned earlier, if those reflections are radically different in timbre and a frequency response from the on-axis.
Yeah.
We hear it and we don't like it. Now, that's not just me saying that. This has all been the Floyd tool research was very much about people's subjective responses to speakers and how that tallied up to the technical measurements of speakers. So it's not some kind of abstract technical theory. It's not personal opinion. Floyd Toole and the guys at Harman, they did listening tests with people, controlled listening tests, and they tested maybe 70, 80 different speakers, and they got to the point where they could predict from the anechoic measurements of a speaker what people were going to say they were going to like. So it's backed up by real subjective research.
Yeah, and look, I've listened to there's a YouTube video of him summarising all of his testing and R&D over the years beautifully. I mean, he's a great speaker, and no pun intended. And it's a great lecture. You've seen the video I'm referring to. It's a relatively recent one, and I remember when I looked at it maybe 2 years ago or something that you had various YouTube bloggers with 200,000 and 300,000 views, and I think poor old Floyd had like 80,000 at that stage, or was it 8,000 or something? I'm like, how is it this guy is a genius, more or less, and certainly offering us this plethora of useful information that is an enormous amount of research and testing and what have you's gone into, and some guys over on another YouTube channel blithering about some piece of audio gear that he's been gifted to write a review about, and he's getting way more gravitas. You're like, there's something wrong in the world, right? But yeah, he's a great person to listen to. And the only thing I would say, though, because I agree with your thoughts on it, but Harman not building great speakers, though. So what? There's a disconnect, is there, or what happened there? Do you think?
Well, as always, as we've already discussed, marketing does get in the way.
Yeah.
It doesn't so much affect maybe smaller businesses like ours, because we've got more latitude to do what we as designers want. But if you're working in a big organization like Harman, JBL, they're part of the sister company and so on, the bottom line of that business is to make money. We all need as businesses to make money, but
they got to make lots of money.
They got to make lots.
They got to pay Mr. Toole's wages for a start. I don't know. He's not actually there anymore, is he? He did.
No, he's retired.
He did 10 or 15 years there, or something like that.
Yeah. So they have less latitude to do, as we've already discussed, to do anything radical. So and actually Floyd discusses this because he had his own arguments within Harman, I believe,
no doubt, yes.
About the marketing people getting in the way, and saying you've got you can't have that shape, you can't have that color, you can't have a tweeter looking like that, and you can't put it there.
You can just imagine he probably wheels in some hideous looking contraption that fulfills all of the requirements except the aesthetic ones, and they're all falling about, like, what is this, but this is, and of course it probably sounds amazing, and the sound is uber saleable, but yeah, getting it, I mean, that is the trick.
There's more to it.
That's the trick of loudspeaker design is to get the customer expectations and hopes to match the sound that they would aesthetically to the sound that they would like to hear, which I'm pretty sure Mr. Toole's got that bit pegged, even though we are using North Americans as the ears for this testing. You got any thoughts on that at all?
Actually, yeah, because there was there was one test that they did do, because there's this concept around that people from different countries have different tastes in audio sound and and whatever. So they did an experiment. They had an identical set of speakers, good set of speakers, and the only difference between them was there was slightly different voiced crossover.
Okay.
And they did the controlled listening tests in various different countries.
Yeah.
And the results came out as everybody liked the same thing and disliked the same things.
Okay. All right. Oh, so they took two pairs of speakers that were largely to look at, but they had tweaked the crossover to
Correct.
have it perform less well. Yeah. Okay. And then obviously,
that's one thing. Part of the controlled listening tests, you wouldn't be able to see the speaker because you get biased by what you see.
Of course. Yes.
Just to point that out. So it turns out it's a complete fallacy that there's a European sound and an American sound, or an Australian sound. It's a complete fallacy.
Yeah, I think it is a complete fallacy as far as the preference of the listener, but I think that those three parts of the world certainly produce different sounding products, though. But I mean, I'm not sure why that is. I mean, and I guess it was historic more than current, perhaps. Like I think in the 70s and 80s when... 60s, 70s and 80s when measurement wasn't as accurate, measurements were not as easy to come by. I think that there was more character in loudspeakers in some cases, although I always think that the best engineered ones tend to rise to the top and be the more well-loved examples of those years of production. But I think that the English speakers did sound different to American speakers, and I think they did sound probably different to Australian speakers. Not that we have as many to choose from, but I think that there's differences there. But I think, humans probably prefer the same sound. But I always wonder about some Southeast Asian, Chinese area type countries and their jingly-jangly music, and which sounds to our ear, my ear at least, quite jingly-jangly, to use that musically technical term. I just wonder whether they do prefer a sort of brighter, less, warm, sweet sound, or is that just up?
I don't know, but I mean, you could suppose that that sort of high frequency content music that I think a lot of Westerners find a bit grating.
Yes.
Not being bagging it or anything.
No. I mean, clearly
different. Yeah, it's just a cultural thing.
And we are talking historical music, I think, probably mostly, rather than they might be producing today. But you've got thoughts on that?
Yeah, maybe lots of high frequency content will have different requirements of the speaker than maybe, say, Western rock music, for example. Although that does sort of conjure up a problem, because I don't believe that speakers need to have different sounds to suit different genres. A good speaker is a good speaker.
Absolutely, yeah, of course.
If it sounds good with jazz and accurate with jazz, it will sound good and it will sound accurate with rock or whatever. That's another subject.
It is another subject, although I have to say I agree. Although the weird thing is that, and this is a thing that annoys me at hi-fi shows. Lots of people get annoyed by hi-fi shows. One would wonder why anyone went, but they do tend to play jingly. Okay, here I go. I'm not going to say jingly jangly again. Let me say
noodly jazz.
Very lightweight, simple recordings that are almost bordering on being sound effect discs than they are pieces of music. And why don't you just put Fleetwood Mac on, AC/DC, or some rap of some description, or techno, and why don't you play the music that the people are going to play? And I think it's because there is this, in the high end, not in the real world of affordable audio equipment, but perhaps in the far high end in some cases, they're just in love with almost sound effects, like
Yeah.
Like it's the oddest thing. Do you find that? I mean, I don't know if you've been to any shows much lately, other than your favourite local shows, but
yeah, I mean, I won't mention the brand, but I did go into one brand's room, a high-end brand's room, at a show not so long ago.
Yeah.
And I really was quite curious about these particular speakers, and I wanted to listen to them. And they put on this well, it was not literally atonal noise, and I couldn't recognise it as music, and as such, I couldn't actually discern what the speaker sounded like.
Yes.
So I legged it quite quickly.
Yeah, and that's an example of exactly what I'm talking about. So we don't know what that's about, I mean, do we? Or do you have thoughts on why they do that?
Well, yeah, I mean, of course, we're hi-fi shows. Let's be honest about this. We're trying to sell to people.
Absolutely.
We're enthusiastic about our product. We think it's great. We want people to love it. So we want to show it off to its best ability. So if you play Bat Out of Hell, which is probably one of the worst sounding albums I've ever heard, it's going to sound rubbish. So you want to put on recordings that sound good.
You do,
yes. But it's getting that balance of finding recordings that are interesting, that people are going to like. But one of the things I love about hi-fi shows is people asking for requests, and I'm finding all sorts of different music I've never heard before, and it's absolutely fantastic.
Well, some of it is.
You do get the odd customer that comes in with something that is just mind-bendingly awful, and you have to shut it off as quickly as possible. But
yes, it's
there's always a degree.
It's a fine line between. Well, there's, and we won't talk. We're going to talk about shows on another occasion, but because we will need to wrap this particular podcast up shortly.
Okay. So let me quickly go back to speakers and and cones and horns, just very, very quickly.
Yeah, we didn't quite finish the wait. Let's call it a waveguide. So, which is really just another name for a horn.
So as we were discussing, the directivity of a speaker is critical to how you perceive the sound when it plays in a room. If you're actually listening outdoors, all you'd be really, although there is a reflection off the floor, obviously, but because there's no walls or ceiling, you'd predominantly, if a speaker had a good on-axis frequency response, you wouldn't actually be too worried about the directivity, because you won't be hearing it, what's coming out the side of the back.
Yes.
So if it was a good on-axis frequency response, you'd like it. But of course, we listen inside rooms, so directivity becomes a very important influencer to how the speaker will actually sound to us in the room. So directivity is critical. I just keep saying it. Directivity. So why do we have three-way
directivity? Done.
Directivity.
I've got it.
Yeah. So why do we have three-way speakers? Well, it was one way to solve the differing directivities between driver sizes.
Mm-hmm.
So going from a very large, now a 6-8 inch woofer to a maybe 3 or 4 inch mid-range, you could keep the directivities similar at the crossover point. So there's no sudden change in directivity. With two-way speakers are very, very often compromised, because you're going from a very large woofer, and at crossover you're suddenly switching over to a small tweeter. So you go from a narrowing directivity at the woofer's top end to a suddenly bursting out to a very wide directivity where the tweeter takes.
I think I'm onto it. So
what that will mean,
okay. You explain it, but I think I know where you're going. Yes.
Yeah. So what that will mean on a two-way speaker is that very typically the directivity suddenly gets wide as you go to the tweeter, and that means there's lots more sound power going into the room at that point.
Yeah.
So there's a sudden disconnect in the amount of energy that you're hearing as the tweeter takes over, and that's why so many speakers, while I started looking at waveguides, so many two-way speakers to me sound relatively bright and hard in the mid-range.
Yeah.
It's because they might have a very flat on-axis frequency response,
Yes.
but because of the extra sound power that they're putting into the room, what you hear at the measurement point, or your ears, should we say, suddenly has a lot brighter, lot more energy at that frequency.
Yeah, just to clarify that, well, it's not something I would normally say in regard to your explanations, but I think what you're getting at is if you have a 1-inch dome tweeter, attempting to blend it with a 6.5-inch bass mid-range driver, that there is a good chance at the crossover frequency without a waveguide that the output at the low end of that 1-inch tweeter diaphragm's range is very wide. And of course,
Yes.
the 6.5-inch bass driver at that same frequency where the two are meeting and being crossed over, of course, has narrowed up and is to some degree, not beaming, but certainly has narrowed right up because it's at the upper end of the range of that driver's capability. And so, yes, the disconnect is that at, say, 45 degrees off axis, the 6.5 at, say, 2.5 kilohertz is quite narrow and very little output at that 45 degree position, but the tweeter at 45 degrees at that frequency has enormous output, and maybe we could be talking 6, 8 or 10 dB more perhaps. And so that is difficult to control and then manage also good on-axis response. So this is where your waveguide comes in, and I take it, as no expert on waveguides, I've not experimented with them, but I'm guessing that it narrows up the tweeter's response at that crossover frequency. Is that the gist of it? To sort of more closely match that of the 6.5.
Correct. Absolutely spot on. So whereas we used to go to a 3-way driver system, where the physical size of the mid-range driver would help it match the directivity of the woofer and then match into the directivity of the tweeter. Mm-hmm. We can actually, with a 2-way, if we add a waveguide, it does exactly what it says on the tin. It narrows up and controls the wave front coming out of the tweeter. So at the lower frequencies where it's taking over from the woofer, it's narrower and much more closely matches the woofer.
Indeed.
So that means the sound power going into the room is similar from the woofer and the tweeter. So the reflections you get off the walls are also similar.
Yeah,
which is humans like. We like it.
It seems. I mean, I guess, and I'm going to play devil's advocate for a second and say, well, that's great. That makes sense, and that has got to make the crossover development, the ultimate result better, one would assume, and perhaps simpler. But what do you think, if any, are the trade-offs of using a waveguide then? Because I guess everything in science is a compromise to some degree. So what do you think there are any real is there a downside other than cost, perhaps?
Yeah, absolutely. They are difficult to design.
Okay.
You need some pretty sophisticated software to design a waveguide that's going to do what you need it to do properly over the frequency range it's got to cover, because you might need to cover from 1 kilohertz up to 20 kilohertz.
Indeed, yeah.
And sometimes you'll see in waveguides at the top end and around 15 to 20 kilohertz, they can get a bit wobbly.
Yeah, okay.
In their terms of their frequency response. So it's difficult to get right.
Okay.
So they are difficult to design. There's no doubt about that. They do have some other advantages because they're narrowing up the directivity at the low end. You can they actually get more effectively more sensitive. They get louder, so you need less power. That low end, which means you can actually cross them over lower, because they don't have to work so hard. They don't have to have such a large extension on them.
Indeed.
So that can be very helpful with two-way speakers. Other disadvantages? Well, yes, they do cost more, and you have got to get them right, because I say about this directivity. If you measure the frequency response with a microphone in a room from a pair of speakers, if those pair of speakers in an anechoic setting had a perfectly flat on-axis frequency response, you measure it in the room, they have a sloping frequency response.
Yeah.
It slopes downwards. And this is very simply because the sound power falls as you go up in frequency.
Yep.
But this is what we're used to hearing. Any sound producing object, whether it's a violin, a guitar, in a room, will have directivity, and you will always find that it will have a sloping frequency response going down as you go up in frequency. Mm-hmm. So it's what our ears are used to hearing. But with a speaker, you've got to get that slope right.
Yeah.
And there's no categoric exactly right answer. I can't tell you that 6-degree slope is right.
No,
because it's got to be sloping, but you've got to get it right, and it's a balance of the specific speaker design, its directivity. The room also plays a part, so that will change the slope.
Indeed, and you are talking about the room outcome. Effectively, yes. The power response. The listener is on the lounge, yes, listening to the stereo, and it is the resultant of all reflections, etc. And of course, every room is different, so that's going to be hard. And personal taste, I guess, is part of this. Some people prefer perhaps a warmer balance or what have you. But yeah, so you are engineering for a more or less flat response on axis anechoically at a small, like a meter or two away from the loudspeaker. That's a design goal with your loudspeakers, is it? Is that?
Yeah, the typical measurement distance is 2 meters, and you normalise to 1 meter for sound pressure levels. 2 meters because it takes a certain amount of distance for the drivers to blend from the cabinet. We won't go into that in too much detail. So yeah, on-axis frequency response, flatter and smoother the better.
Yeah, okay.
But you need a falling sound power, yes, as frequency goes up, which will lead to a falling in-room, what we call an in-room response.
Yep. Well, I find that all very interesting. I guess I know some of it, but to have it turned around and presented to me and presented in such an eloquent way, Alan, has been a great pleasure. And I think the listener has probably enjoyed your explanations of various things, from blades flying off jet engines and how the aircraft passengers are protected by some kind of scatter shield built into the engine cowling or something along those lines, or however that works, through to waveguide design and the fact they're not really a horn. I'd love to have you back on the show, and I think there's many things we could discuss. I want to discuss the Concorde and whatever you know about that, because it's probably the most amazing machine ever invented on the planet, ever, even though it was a 70s thing. And also those other things that you do, which are amplifiers, which we've kind of ignored, and
yes.
and because I believe they employ Class D technology, and that's something we can talk about, because it can work extremely well, and in fact is probably, I guess it's the newest amplifier thing under the sun. It's not the newest. There's other things that have come out recently, I think, that are not new semiconductor technology, at least. But we'd like to talk about that more. So would you be interested in coming back for round 2, sir?
Oh, absolutely.
Absolutely.
I wish we had. We might have to do a video podcast, because some of this needs diagrams to help people understand.
Oh, crikey! Does it really? Have you got a whiteboard there or something that you? Gee whiz.
Oh, but just a very quick one on Class D amplifiers. Did you know? Do you remember Sir Clive Sinclair, who invented the
Z80
Sinclair compute? Z80, yeah, and the little electric trike thing.
Yeah,
idiot.
Are you having a crack at trikes? What the hell?
Yeah.
I think his might have had one wheel at the front, so that's never going to work.
He actually released the first Class D amplifier, and I think it was 1967.
Yeah. Okay. All right. So what using transistors, I'm going to guess, very early. Germanium transistors or something, but...
yeah, it didn't last long because it was more like a radio transmitter, but it's a concept that's been around for a very long time.
Well, yeah, and I guess people don't realise the engineering behind the whole. There's many classes of amplifier, and they're really a description of distortion characteristics and what have you, and range, frequency, how broadband they are or otherwise. I mean, there's the whole class A, B. Is there a class C? I've kind of forgotten whether there was, but there's
there is. Yes.
Yeah. I had a feeling there was, and I think that's used in RF applications or something. But yeah, there's E, D, F, G, H, I, J. There's certainly H, and there's certainly G, and there's a bunch of others, I think. So yeah, well, that's it. That's an exciting possible title for a new podcast. Is amplifier topology and various classes, but we might stick to Class D since your product uses them, and so do many others these days. In fact, it's what did I see in a news feed the other day? A new fancy Marantz amp, and it's going to have Class D. I think your friend, Mr. Putzi, is that how you pronounce his name? His ideas are in it somehow. So I mean, everyone is. I think Marantz have done Class D before, but this is a new look at it or something. So anyhow, I'll stop showing my ignorance and we'll wrap this up. Thank you again, Alan. It's been enlightening,
very welcome.
and a lot of fun. And thank you, people, for listening. And of course, go to the website, notanaudiophile.com, and all of that. Like and subscribe and blah blah blah. And feel free to comment on YouTube, because by the time this broadcast goes up, it will be on YouTube, and you'll be able to comment and say all sorts of nasty things about Alan and I. Well, mainly about me, but and we'll love it, because we love that sort of thing. We didn't get onto that, Alan, how you love a good internet discussion, but we will next time. So thank you, and we'll talk again soon.
You're very welcome. Looking forward to it.
Thanks, Alan.